Let's take a look at the free response question number 1 on the circuits review packet. We're given a battery voltage, let's call that an EMF of 9 volts. And then we're also told that, that it has a value of 9 volts and that it has an internal resistance of 1 ohm. That's something we haven't spent a lot of time talking about. You can treat it as just a separate resistor in the circuit. However, now they're asking, later then they say there's 3 amps leaving the battery and the power dissipated in R2 is 12 watts. So they want to know the voltmeter reading. Well, the voltmeter is reading what's called the terminal voltage, or the difference between the top and bottom rail, if you will. But it's going to be 9 volts, but then there's some voltage dropped here at that 1 ohm internal resistor. Even if it wasn't an internal resistance, the terminal voltage, or the voltage between X and Y, would not be 9. It'd have to be less than 9 because there's some voltage drop there. I'm going to use Ohm's law, V equals IR, locally at this 1 ohm resistor. We know the current going back into the battery also has to be 3 amps. So we have 3 amps, and we're going to multiply that by 1 ohm. And so therefore, we're going to have a voltage drop of 3 volts. Here's one way of thinking about it. The voltage between X and Y is going to be equal to the rated battery voltage, E, minus that voltage drop across the internal resistance. I can write it as E minus IR, or I could just write it as, 3 volts in this case. So I'm going to end up getting 9 volts minus 3 volts is equal to 6 volts, which is the voltmeter reading. That's what the upper rail, the difference between the upper rail and the lower rail will be. And that's the answer to part A. In part B, they ask about the resistance of R2. Now, we're given some interesting thing. We're told that the power dissipated by that resistor is 12 watts. We also happen to know that the voltage drop across resistor number 2 is equal to 6 volts. How do we know it? Well, we kind of figured out in part A. So we have the voltage and the power, and we're being asked about the resistance. Well, power is equal to voltage times current. We don't know the current going through R2. We can eventually find it, but we don't know it quite yet. So let's go ahead and start thinking about some substitutions that we could make. We know that V is equal to IR, and if I solve this for I, it becomes V over R is equal to I. And that's what I'm going to end up substituting here into I, and I get power is equal to V times V over R, or V squared over R. And now I have power and voltage, and I'm looking for resistance. So I'm going to solve that for resistance, and this becomes resistance is equal to V squared divided by the power. And the voltage is 6 volts, so 6 times 6 is 36, and I'm going to divide that by the power of 12 watts. And 36 over 12 is going to give me a value of 3 ohms. And so now I have the resistor value for R2. In this last part, I want to figure out the resistance of R number 1. And it honestly is a tough problem. The key to unlocking this one is recognizing that I need to know, I already know the voltage dropped across R number 1. It's also 6 volts, right? All of these resistors in parallel have 6 volt drops. So I know the voltage, and if I knew the current going through resistor number 1, I could solve for the resistor value itself. I don't know the current going through it, but I do know the current, or I can figure out the current that's going through R number 2. How can I do that? Well, I know all this stuff about it now. I can say V is equal to I times R for resistor number 2. And I can solve for the current going through it by dividing the 6 volts by the 3 ohms that I just solved for in part B. And so therefore, I can see that 6 divided by 3 is 2 amps is the current going through resistor number 2. So that's current going through resistor number 2. Well, this is now a node law application, right? So if 3 amps flows in, 2 amps goes off to the right, that means that 1 amp has to go down through resistor number 1. Now I know the current going through it, and I can unlock this problem. I know the voltage and I know the current. I'm going to divide both sides by the current, I1, and that will allow me to solve for the resistor value, R1. I'm going to plug in these values. It's going to be 6 volts over 1 amp, and that's going to give me a 6 ohm value for resistor number 1. And so that's my final answer for part C of FRQ number 1.